Good morning students. Today we will discuss about PN junction formation. Okay, last classes we have seen what is intrinsic semiconductors, how to get extrinsic semiconductors from intrinsic semiconductors. Next, how extrinsic semiconductors are divided into N-type and P-type semiconductors. Now, what are intrinsic semiconductors? Intrinsic semiconductors are pure form of semiconductors. When these are doped with impurities, they will be converted into extrinsic semiconductors. So depending on the dopant material, depending on the added impurity, these extrinsic semiconductors, they are divided into N-type and P-type semiconductors. Now, P-type semiconductor, if I take P-type semiconductor, what are the majority charge carriers in P-type? Holes. These holes are produced from doping trivalent impurity. So these trivalent impurities, these holes are ready to accept electrons. That's why these trivalent impurities are also called as acceptor impurities. So in P-type, majority charge carriers are holes. They are produced due to acceptor impurities. In N-type, if I see N-type, here in N-type, what are the majority charge carriers? Majority charge carriers are electrons. They are produced from pentavalent impurities. Okay. Now, these are donated by donor impurities. These are produced by donor impurities. Now, how to form PN junction? This is the P-type semiconductor and this is the N-type semiconductor. How to form PN junction? See here, PN junction can be obtained from three methods. One is grown junction type, fused junction type, diffused junction type. Means if I take any one, see here, how to produce this PN junction means if it is grown junction type, if I take a slab. So to this slab from one side I will insert N-type dopants and from other side P-type dopants. So I can form PN junction. So these are the techniques to prepare PN junction diode. Okay. Now if I go for PN junction formation, now see here in P-type semiconductors. In P-type semiconductors, what are the majority charge carriers? Majority charge carriers are holes which are produced by acceptor atoms. These holes are generated by acceptor atoms and few thermally generated minority charge carriers. Minority charge carriers are electrons which are shown in figure. Now all of you listen to me. See here this is the conduction band and this is the valency band. Now where does acceptor level lies? Acceptor level lies just above the valency band. Now at T is equal to 0 Kelvin, acceptor level is empty. Means they are filled with holes. Valency band is filled with electrons. Now conduction band is empty. At T greater than 0 Kelvin means if I give temperature, what happens? These holes are ready to accept electrons. These holes are ready to accept electrons. So what happens? It is filled with electrons and here holes are created. Now if all the acceptor level holes are filled with electrons, still if you give temperature, what happens is these electrons move from valency band to conduction band. Valency band to conduction band, creating hole in the valency band. So here I can find electrons in the conduction band after giving temperature. So when compared to holes in valency band, very less electrons in conduction band. That's why holes are majority charge carriers and electrons are minority charge carriers. So see here in P-type semiconductors, Majority charge carriers are holes which are produced by acceptor impurities and few thermally generated. These are the thermally generated electrons. Means when you give temperature, we are getting electrons. Those we call it as thermally generated minority charge carriers as shown in figure. So you can see in the diagram. So see here, this is the p-type semiconductor. Holes are carrying positive charge. So see here, these holes are carrying positive charge. From where we are getting these positive charges? From the acceptor atoms. These are the acceptor atoms. Means here these are ready to accept electrons. These are ready to gain electrons. That's why they are becoming electronegative. They are becoming negative. So see here, if I take p-type semiconductor, these are the acceptor atoms. These are the acceptor atoms. From these acceptor atoms, so here these are producing holes, positive charges. Next, these holes are ready to accept electrons, means this atom is gaining electron. That's why they are becoming negative. So these negatives we call it as acceptor ion. It is acceptor ion and these are holes. And few thermally generated minority charge carriers, that is electrons. They carry negative charge. So this is about p-type semiconductor. Next, in n-type semiconductor. Now in n-type semiconductors, what are the majority charge carriers? Majority charge carriers are electrons. So these majority charge carriers are donated by, these electrons are donated by donor atoms. They are donated by donor atoms. Due to pentavalent impurity, we are getting electrons. So here these are the pentavalent impurities. Pentavalent impurities are losing electron. That's why they are becoming positive, electropositive. So these positive ions represent donor ions. And the electrons, these electrons, left electrons, we call it as majority charge carriers. And few thermally generated minority charge carriers. Due to temperature, there will be minority charge carriers. Means see here, this is the conduction band, this is the valency band. Where does donor level lies? Donor level lies below the conduction band. So see here at T is equal to 0 Kelvin. At T is equal to 0 Kelvin, valency band is filled with electrons. Donor level also filled with electrons. There is no electron in conduction band. So if you give temperature, electrons jumps from donor level to conduction band. Okay. Next, after some time, if this donor level is filled, electrons jumps from valency band to conduction band, leaving holes in valency band. So these holes are created when you give temperature. That's why they are called as thermally generated minority holes. So this is p-type semiconductor and this is n-type semiconductor. If p-type and n-type semiconductor are brought close to each other, see here, p-type semiconductor, these are the holes, majority charge carriers. N-type semiconductor, these are the electrons, majority charge carriers. So PN junction is formed when a p-type and n-type semiconductors are joined as shown in figure. So when this PN junction is combined like this, so see here what happens is the electrons diffuses from n region to p region, means these electrons move from n region to p region and these holes move from p region to n region and recombination takes place only at the junction. At this junction only recombination takes place. So here they are diffusing, charge carriers are diffusing from one region to other region. That's why it produces diffusion current. This current is called as diffusion current. Now formation of depletion region. How to form the depletion region? Now see here. Now what happens? The electrons and holes here, actually holes should be there, here electrons are there. what happens? Electrons and holes recombine. These electrons and holes recombine and they produces light or heat. So here no more electrons and holes, means mobile charge carriers are not present. So see here, the majority holes diffusing out of P region leave negatively charged acceptor ions. Means here what happens? This electron combines with holes and holes recombine with electrons and they will be converted into light or heat depending on the semiconductor. So what are left? On P side, acceptor ions are left. On N side, donor ions are left. So on P side, negative charge is accommodated. On N side, positive charge is accommodated. Okay. So see here, the majority holes diffusing out of P region leave negatively charged acceptor ions, Na on P side. Next, see here, and positively charged donor ions on N side. Now what happens is this electron want to cross the junction. This electron wants to cross the junction. But electron is having which charge? Negative charge. On P side we have negative charge. So this negative repels. This negative repels and this electron stay here only. It cannot move from N region to P region. Next, here also this hole want to cross this junction. This hole want to cross this junction and this want to cross this junction and want to enter into N region. But here hole is having positive charge and here this is also positive charge. So positive what happens? They repels. Positive repels and they stay here only. Means there is no further recombinations. So this layer which is lack of mobile charge carriers, means in this region I cannot find mobile charge carriers. I can find only immobile charge carriers. So this I call it as depletion region. This I call it as depletion region or space charge region. Okay, or otherwise we call it as potential barrier. Okay, next. So see here, next. Here, this we call it as unbiased PN junction. So here electrons diffuses, holes and electrons diffuses and there will be depletion region. Here I am not giving any external source, but there is a current due to majority charge carriers, that we call it as diffusion current, and there may be current due to minority charge carriers also. Okay, next. So see here, the depletion region. Here the narrow charge which is depleted, means which is lack of mobile charge carriers, is called as depletion region. The width of depletion region is 1 micrometer. Okay. Next, if we further move for junction voltage or contact potential. Now see here positive charges are accommodated on N side. Negative charges are accommodated on P side at the junction. So here positive charge is concentrated at one place and negative charge is concentrated at another place. Means there is a concentration gradient. Positive on one side and negative on one side. This we call it as potential difference. So see here, as negative ions are created on P side, so P side acquires negative potential. Similarly, as positive ions are created on N side, so N side acquires positive potential. Okay. So due to charge separation, a voltage, the potential difference is created, which is represented by V0, which is called as junction potential or contact potential. Okay. Means without giving external source also, PN junction is having certain voltage. That voltage is due to diffusion of electrons and holes from p region to n region and n region to p region. Okay. Now this contact potential for germanium is 0.3 volts. Means without applying external source, it is having certain voltage, that is 0.3 volts. And for silicon it is 0.7. For silicon it is 0.7 volts. Okay. So this is about p-n junction formation, and this is about formation of depletion layer, and this is about junction potential or contact potential. Now if we see for the diode symbol, the symbol of the diode is like this. So this represents anode. This is the positive terminal and this is the negative terminal, and this represents anode and this represents cathode. The direction of the arrow gives the direction of the current. So this is about p-n junction diode. Thank you.